At this point, it's time to start building your EV3 robot. So, what we are going to do is we are going to build what is called the tracker robot. And when you purchase one of these LEGO Mindstorms kits, they come with some predefined construction plans that you can build. And what we're going to do is we're going to use one of the predefined plans that they give us, which is called the tracker. And this is a kind of like a tank. It's got track wheels, and it's got a variety of sensors that you can attach to it. And it's a good idea to always start with a plan that is either provided by LEGO or is widely understood, because there's a lot of support that goes along with that. For example, like this tracker one has all these different support options. So you can have an app for your phone that you can control it, run it like a remote control car. It has a bunch of different plans, or a bunch of different features where you can control it with the IR remote control beacon. And so it's always good to kind of build one of the predefined plans and just get familiar with what the pieces are in your kit and how they go together and what the capabilities are before you go off and start designing your own robot. Okay, so what we're going to do is we're going to build this tracker, and I'll show you the plans. Now we're only going to build up to the point where it looks like this, and then we'll attach our own custom sensor to it, which will fit kind of what the challenges are in this course. So at this point, let's take a look at the actual plan itself. So this is a PDF file, and this is the 31313. That's the model of your kit. And you'll notice that this is a picture of the final construction, and there's a whole bunch of stuff on here. And we're not going to put all of this on there. What we're going to do is we're just going to build through instruction number 12, but this shows a picture of the last final assembly. So the way that these construction plans work is they're very graphical. So you're going to have, it's going to show you what you're trying to accomplish, and then it's going to show you the piece parts and how they go together. And they're going to have, they're going to tell you the quantity that you need for this particular assembly, and then you just kind of walk through all the steps, and it's very graphical. So let's take a look at what happens when you open this kit. Okay, so when I kind of mentioned before, the kit that I got was the retail kit, which means it has certain sensors in it, and then there's the educational kit, which has a different set of sensors. So when you open the kit, the one that I got just came in a cardboard box, and everything was in bags. So the first thing I did is I went and bought a tackle box. So this is a way to kind of keep everything organized. So in this situation, what I did is I spent a little bit of time trying to organize all the pieces kind of somewhat logically, and so I just separated them by size and all that sort of stuff. And so one of the first things that you'll see when you open this kit is you're going to have the brick, all right, which is the brains of the operation. So this right here is the computer system. And the way that it works is it's got a variety of ports on it. So you'll see that there's 1, 2, 3, and 4, and then A, B, C, and D. And ports A, B, C, and D are used to connect your motors to, and then 1, 2, 3, and 4 are used for the sensors. The other thing that you notice, so this is the main component, and this is where we download our programs onto. This is where the batteries go into, and you can buy rechargeable batteries and put it in there. I'm just using AA batteries right here. The batteries are a really big concern when you do this programming, because when the robot batteries go low, the behavior of the robot is really sporadic, and sometimes you'll be changing your program over and over to try to get the robot to do what you're telling it to do, and it just doesn't respond. And what I've found is one of the first things to check is that your batteries are charged. So keep that in mind as you build. And then you'll notice that over on the side here, this is my tracker. I've already assembled it. You'll see the servo motor. They're the things with the red circles on it, and you can spin them and you can kind of hear the gears inside of it. And so those are the servo motors. And notice that I have, I use these cables that are provided in order to attach the servo motors to here. And this tracker right now we don't have any sensors on it. We'll attach those once we start talking about it. But when you look in your kit, you'll also notice that there are sensors. So you'll see a variety of different, light sensors and IR sensors and push button sensors. And you'll also see, wheels and just anything that you can imagine is in here. Now, a couple things that I want to mention as you build, which are things that people really get tripped up on, and it's not explained very well. So when you pull out these pieces, one of the things that you'll notice is this is called a beam. Okay, so this is a beam, and it's really one of your primary building blocks in here. And the beams come in a bunch of different sizes. They come in short ones, and then they come in long ones. So all sorts of different sizes. The way that these are called out in the construction plans is they call them by a number, and the number is associated with the number of holes in it. So for example, when you look at this, you'll see that there's 1, 2, 3, 4, 5 holes in this, and so this is called a 5 beam. So that's how they tell you which size it is. And then this, I think, is a 15 beam. And that's how you can determine what piece part that they're actually telling you to grab. So let's see if there's an instruction in here that uses a beam really quick. Okay, so here's an example. Notice over here, it's got a 13 by it. So if you look at this 13, that means that you're going to grab a beam that's got 13 holes in it. The other thing that's really important is there's these other components that are called axles. And you'll notice that the axles also come in a variety of different sizes. So if I go over and I grab, an axle. So like here's an axle right here. What these have sizes too, and the way that these are sized is that they correspond to a particular beam size also. So if you had an axle that was, I don't know, let's say that this axle, if I hold it up next to a beam, this is a 7 beam, so the axle's a little bit larger than it. So if I looked at it, I would grab a 9 beam, and that would let's see if it matches a 9 beam. So notice that here's a 9 beam, so this matches, so it's like, oh, okay, that's a 9 beam, 9 axle. Okay, so that's what the number refers to. It's just the number of holes in there. Okay, and then they have all these other ones. When you have a turn on the beam, they will call it out as so here's a beam that has a turn in it, and they'll call it out as the number of holes by the number of holes on the horizontal or on the perpendicular. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So this would be a 7 by 3 beam. So that's just the terminology that you use in there, and it's not really explained anywhere, so it's kind of helpful just to talk about it. And then each of these piece parts that are in here, they all have little names, but one of the things that's neat about it is that the construction plans are very graphical. So they really just show you, what the piece is, which piece goes in there. They're color coded, so it's easy to kind of see what's going on. Now, here's a big piece of advice that I will give you when you do this. When you build, try to orient the pieces just like they are oriented in the picture. So for example, this beam right here, I want to orient it so that it matches the picture exactly. And then I would come in from this side and put the blue piece in there. And it really makes it helpful to do that when you teach people how to do this, is orient it exactly like the building plan so that you don't get confused. And this helps when you have to flip things left and right. And it's actually kind of a powerful skill to develop. They've always talked about how engineers require this visualization, and they always talk about this ability in your brain to take a three-dimensional object and rotate it. And it's kind of a skill that if you can do it, you can become, it's something that's a trait of an engineer. So it's something that can be developed, and this is a really good way to start developing, is just thinking about these three-dimensional geometries and how they spin and how they rotate. And so when you first get started, go ahead and just orient it directly like the construction plan shows. Okay, so what you're going to do is you're going to build the tracker, and you're going to go through instruction number 12. So instruction number 12 is basically where you end and you connect the motors together, and this is what mine looks like, so right there. And so what we're going to be able to do is this will provide us the ability to do locomotion, and we'll start moving this tracker around, and we'll look at how we turn it, and we'll look at how we accomplish tasks. Again, we don't have any sensors on here, which is fine. We'll add those once we get to it. But this is the end product, so you're going to go ahead and do that. And then really the next step is to start installing the software and actually talking to the tracker and look at how we can create rudimentary programs and download it on it and make sure that everything's hooked up right. And then we'll be able to start looking at more complicated programs to make the tracker do even more sophisticated tasks. So that's the next step.